So we learned how to do this, but I just want to review with you real quickly. I guess the first thing I would mention is that we have a closed interval. Right? And our AB, our closed interval AB is in this case is going to be 0 to 2. So for sure, we know that it's going to have a absolute maximum and minimum as long as this function is continuous. So the next thing I want to say is that f of x is continuous. Now, how do I know it's continuous? In this case, this is not a polynomial. In other words, a polynomial has integer powers. So like if this was a 3, it would be a polynomial. But this is not a 3. This is a 2/3. So this is actually some sort of a radical function or a power function. But we can still show it's continuous. Does anybody know how I could show something is continuous, even if it's not a polynomial? It's a calculus idea we can use. The way that we're going to show it is we're going to calculate a derivative, right? So let me not say it's continuous right off the bat. Let me calculate the derivative first. When I calculate the derivative over here, our derivative is going to be f prime of x. And this is just a power function, right? So I could really write this as the derivative is going to be 2x minus, I could bring the 2/3 down in front. That's going to give me a 2. And then I can subtract 1 from the exponent. When I subtract 1 from the exponent, that's going to give me an x to the negative 1/3. Okay. So, so if the derivative exists, then that means it's going to be continuous. Now, now that I look at this, I see that we have a problem. When I look at this, I can see that this is continuous. So this is differentiable. Differentiable except at x equal to 0. Okay. So so actually now this makes me a little bit nervous, because why is it not differentiable at x equal to 0? You can't have a 0 in the denominator over here. So actually, if you don't mind, let me just double check. Let me try to graph this in Desmos and make sure that nothing too crazy happens. So if I go over to Desmos here and I try to graph that function, we get y is equal to, it was x squared minus 3 times x to the, and then what is that? That's 2/3. Okay. So when I graph this here, what can you see? You can see now why it's not differentiable. It's not differentiable at that point, at the origin, 0, 0. And the reason why is because we have a cusp at that point. Okay. So it's okay that it's not differentiable there. We needed it to be continuous. So I guess in this case, I'm saying it's continuous by looking at the graph more than by looking at the derivative. Okay. So we can tell it's continuous by looking at the graph. Okay. So So what do we want to do next? Once we found that it's continuous, the next thing we want to do is we want to find the critical values. So we find the critical values. How do I find the critical values? I take the derivative and I set it equal to 0, right? See all the points where it doesn't exist or when it's equal to 0. So I'm going to take this that first derivative, I set it equal to 0, you set f prime of x equal to 0. We're going to get 0 is equal to 2x minus 2 times really 1 over x to the 1/3 power, like this, right? And then I think what I'll do next is I'll put this under a common denominator. So when I put this under a common denominator, I basically want to take this 2x and want to multiply top and bottom by x to the 1/3 power. So that's going to be like 2 times x to the x times x to the 1/3 power all over x to the 1/3. So that first guy is not changing. The second guy already has the denominator, so that's going to be minus 2 over x to the 1/3 power. And then when I combine these, I get 2x to the 4/3 minus 2 over x to the 1/3 power. Okay. So this allows, I can factor out a common factor 2 here, right? I have a 2 and I have a 2 here. So I can factor out the 2. So I get 2 times x to the 4/3 minus 1 over x to the 1/3. So when I go to find my critical values, I plug in a c and I set it equal to 0, right? So this tells me that I'm going to have 0 is equal to 2 times c to the 4/3 minus 1 divided by c to the 1/3 power. So I know that if I have c to the 4/3 equal to 1, that's one equation. I have c equal to 1/3 equal to 0. That's the second equation. This top part here tells me f prime equals of x is equal to 0. This bottom part tells me that f prime of x does not exist because you have a 0 in the denominator. Does that make sense to everybody? Is there any questions? Okay, so what number when you raise it to the 4/3 power is going to give you 1? Well, I think there's a couple choices. One choice is you could put in a 1, and that's definitely going to give you a 1. There's one other number that you could put in that will also give you a 1, and that number is -1, right? So if you put in a -1, the cube root of -1 is -1, and then you raise -1 to the 4th power, and that's going to give you 1. So we're actually going to get c equal to plus or minus 1. But remember, our interval only goes from 0 to 2. So this just tells us that c is equal to 1. As far as when the denominator is equal to 0, I hope you can see that the cube root of 0 is equal to 0. So this tells us that c is equal to 0. Okay. So what we need to do is we found out all the points we need to test. We need to test the endpoints, which is going to be f of 0 and f of 2. We also need to check that critical value, f of 1, because 1 is inside our interval. Okay. So what do we get? F of 0, you're going to get a 0. F of 2, you're going to get 4 minus 3 times 2 to the, times 2 to the 2/3. And I think when you work this out, you get something like -0.762 if you use your calculator. And then f of 1 is equal to -2. Okay. So I think that the biggest of these numbers is going to be 0. So this is the absolute max. And the smallest of these numbers is going to be -2. So that's the absolute min. Does that make sense to everybody? Is there any questions about this? All right, cool. So let me refer to the graph again. If we're looking at the interval from 0 to 2, I hope you can look at this picture and see our interval from 0 to 2. So maybe I could restrict the graph here. Is it curly brackets that I use? I think I use curly brackets. I go from 0 less than or equal to x less than or equal to 2. Close our curly brackets somehow. Oops. Let's just hit enter. And then you can see, right, at 0 is where we have our max. At 1, we have our min. And at 2, it's sort of somewhere in between. So this graph kind of matches what our calculations show us. All right.